So a bunch of what we're covering today is vocab, these different terms for set notation. And we'll talk about these one by one. Hopefully this will make sense. So first we're going to talk about is sets. Okay, a set is a collection of objects. It could be anything. It could be numbers, it could be animals, it could be shapes, anything like that. A lot of the stuff we'll be talking about are numbers, okay? We talked about sets when we did classifying numbers, so like the set of all real numbers, or like the set of natural numbers, things that you can classify, all right? So like if we were to look at A, these are like odd numbers. We could classify odd numbers, or for like B, we could classify even numbers, things like that, okay? And this is what sets look like. They have these little curly brackets, okay? Do your best to draw those. I feel like I'm not very good at that. All right, so those are sets. Then we have the universal set. Oftentimes it's known as the sample space. So like all the things we can choose from. All right, so the universal set, U, is the set of all possible outcomes. So if we were talking about perhaps rolling die, something like that, we only have 6 outcomes, something like that. I can even draw these, okay? So there's a die, okay? So there are only 6 choices. That's your sample size, or sample space, sorry, or your universal set. All right, and we call that U. Next we have subsets. So C is a subset of A if every element of C is also part of A. So let's just do an example of what they're talking about. Oops, it looks like I did not clear these out. Just ignore that. Let's just pretend like that never happened, okay? So they're asking here, is C a subset of A? I'll highlight that so we know what we're looking at. All right, well, we'd have to look at what C is, and we'd have to look and see what A is, okay? Is C a subset of A? In other words, is all of C, 3 and 5, is 3 and 5 also in A? Which it is, okay? So here we could say yes, okay? Because 3 and 5 is also in A. We could look at another example, like a non-example, is B a subset of A? So we would need to look at those 2 sets. Is B a subset of A? Well, is 4, 5, and 6 part of A? And we'd say no. Okay, 4, 5, and 6 are not in A, so it's not a subset. If we were to like sketch a little Venn diagram of what that looks like, would be something like we'd have a circle for A, and C would be inside of A. Okay, so that would be a good example for here. Okay, or I guess maybe vice versa, we'd draw it that way. All right. So let's talk about another type of vocab is union. So union is a set, the union of set A and B is the set of all the elements that are in A or B. Okay, so another way to kind of think about that, well, union, when you, union is like combining everything together. If you get married, sometimes they call marriage a union. You bring everything together, something like that. Or a union for like a workers' union or a teachers' union. Okay, we all work together to get what we need, something like that. Okay, so it's all together. Another way that we can kind of see that, or another way to think about that, is if we have set A and we have set B and we want to union them, you can kind of think of the U as union, or another way you can kind of think of it as like a bowl, and we're just going to put everything in that bowl. So let's look at an example what that looks like. So A union B. So I already have those highlighted. If we did A union B, which means that we would bring all of them together, we would have 1, 3, 4, 5, and 6. And we wouldn't double count. We have 5s from both of them, but we wouldn't double count it. Okay? So let's write those down. It's going to be hard because I don't always remember what it says. So here we had 1, 3, 4, 5, and 6. I think that was it. Double check. So we had 1, 3, 4, 5, and 6. Okay, so the one thing that you would maybe run into issues if you wrote it twice. So again, we don't double count anything. All right? All right. Now let's do another example. C union D. So we're going to look at the last two. Union those together. So we should have 3, 5, and 6. 3, 5, and 6. Okay? Let's see how this looks like if we were to do a union. So if we had set A and we had set B, the union of A and B would be like we shade all of this. Okay? All of B and all of B, A. Okay? And we could fill in the numbers where they apply and stuff like that, but I don't think we need to do that right now. All right, and then we're going to talk about intersection. Okay, so we've talked about intersects before with graphs. It's where they meet each other. Okay, they share the same point. Remember that? So like if we had a quadratic and a line, these would be the intersections. Okay, it's not much different than that when we do set notation. If we do the intersection of A and C, we want to know what they have in common. Okay? So if we look at A and C, what do they have in common? Well, they share, or sorry, it was A and C. So they both have 3 and 5. That's what they have in common. So we do a set of 3 and 5. Okay? And then let's do the intersection of A and D. So let's go back to that. A and D, what do they have in common? So A has 1, 3, and 5, and D has 6, so they have nothing in common. Okay? And we will just do a curly bracket that is empty. This is called the empty set. Okay? So it's all right if we have nothing in common. All right, if we were to draw like a Venn diagram for that, we'll do the first one, this one. It would be something like, if we had A like this, and we had C like this, their intersection would look something like that. Okay, what they have in common. All right, and next we have is complement. So the complement of set A is the set of all elements not in A. So basically everything except what is in A. Okay? So we said in the past that A is 1, 3, and 5 for our example. Then the complement of that would have to be everything but 1, 3, and 5. And again, we know our universal set is 1, 2, 3, 4, 5, and 6. So this kind of limits how big our set is. So it would have to be 2, 4, and 6. It would have to be the evens. So if A is the odds of the universal set, then the complement of that would be the evens of the universal set. Okay? So I'm going to have all of our homework and on our test using this notation, using like a, whatever that called. What is that called right now? Like a kind of, oh my word. Anyways, it'll come to me, okay? Another way to write it is using this C. This stands for complement. I've seen it both ways. I just wanted to be aware of that in case you run into something like that on the ACT or something like that. But we'll be focusing more on this. All right, so D complement, so everything but D. I think we said that D was 6. So So the complement of D would be 1, 2, 3, 4, and 5. Okay, let's do a little sketch of a Venn diagram for A prime. If this was A, then A prime would be everything except for A. Okay, hope you can see that highlighted. Okay, and then the last thing we're going to talk about is cardinality. That's a fancy word to say the numbers, like the total numbers of elements in a set. So let's just, instead of, these are different ways you can write it. Again, this is how I'm going to have us do it, is n in a parenthesis, n standing for maybe number. Okay, number of elements. Okay, and like this absolute value kind of thing here is another example of that, but it doesn't do the absolute value, okay? Because now we're not talking about algebra, we're talking about probability. All right, so n, the number of elements in B, well, let's go see what B is. Okay, it has 4, 5, and 6, so how many elements are there? N of B would be 3, because there's 3 elements in there. What would be n of C? Well, that would be, we have 2 things, so that would be 2. Right? And then n of D, well, that would be 1. Okay? Or what would be n of the universal set? So we said universal set here was 1 through 6, so that would be 6. So that is how we do cardinality, the number of elements in a set. All right, so let's do a couple examples. Let's talk about universal sets. So what is the universal set for tossing a coin? How many outcomes are there, and what would those outcomes be? So for tossing a coin, you could do like tails, or heads. Those are your only outcomes. Okay. What about rolling a 6-sided die? Well, that could be like 1, 2, 3, 4, which we just did, 4, 5, and 6. Or drawing a marble from a bag that contains 2 red, 3 blue, and 1 white. Okay, since each of these these marbles are like different, we'll need to write all those separately. So we could do, we have a red, and a blue, and a blue, and a blue, and a white. So this would be our set that we can choose from. All right. This is going to be a half of like what your homework is doing something like this. So given a 10-sided die, which means we have 10 numbers, 1 through 10, identifying the following sets. So our first set is even numbers. So we want to write down what the even numbers are from the universal set. Would be 2, 4, 6, 8, and 10. Prime numbers. So again, prime numbers, they only have 2 factors. Okay? And they have to be distinct. Maybe I should put that. 2 distinct factors. So for example, 2 would be a prime number because it can only be divided by 1 and 2. 3, 5, 7, and that's it. Okay? 1 is not prime because it has only 2 numbers that go into it, but they are not distinct. They're the same. So 1 wouldn't be prime. All right, those are just some of those. Again, there's more than just that many because 11 is a prime number, but it's not in our universal set. All right, next we have multiples of 6. So we have things like 4 and 8 and 12 and 16, but those 2 aren't inside of our universal set. And then odd numbers, we have 1, 3, 5, 7, and 9. Okay? So now we can answer some of these questions. So if you would, pause and do as many of these you can, and then we'll go over them. So the Again, this is a union, which means we're going to take everything together. Another way to kind of say that would be or, C or D. Okay. So C union D would combine all of those together. So we'll have 1. We'll have 3, 4, 5, 7, 8, and 9. Okay, so we just take all those numbers and put them all in one set, and we don't double count. Okay? Here is C, so the intersection of A and D. So let's look at C what A is, and we'll look at D. What do they have in common? So 1's not in both of them, 2's not in both of them, 3's not in both, 5's not in both, 6 isn't in both, 7, 8, 9, 10. Okay, because obviously they shouldn't be the same because A's are the evens and D's are the odds. So they will have nothing in common. This would just be our empty set. Okay. All right. Is B a subset of A? So we're going to look at B, see what's in B, and want to see if is all of that also in A. So 2 is in A, 3 is not. So we know straight away that this is not a subset. Okay, and how would know? Well, because 3, 5, and 7 aren't in A. Okay? A prime, we kind of talked about A prime. So A is the even numbers. So the complement of A would be all of the odd numbers. So we could do 1, 3, 5, 7, and 9. Or another way you could have just said was D, because that is. D is the complement of A, and A is the complement of D. All right, the intersection, the number of elements in the intersection of A and B. So what I would suggest is to break this into 2 parts. So we want to just figure out what is this set, A intersection of B. So if we look at that, 2 is in both of them, and that's it. Looks like that's it. So A intersects B is 2. And then the number of elements in that would be 1. Okay. All right, here's just some other examples. Hopefully you gave this one a try as well. So the union of B and D. So we're just going to mash together all of those. So we should have 1, 2, 3. There's not 4, 5, not 6, 7, and 9. I hope I got all of that. Then we do the intersection of A and C. So what does A and C have in common? Looks like 4 and 8. So 4 and 8. Okay. Is C a subset of A? Well, is 4 and 8 also in A? Yes. Okay. Then let's talk about this. The union of B and C and its complement. So first we're going to figure out what B union C is. So B and C, we're going to bring them all together. So it looks like we have 2 and 3 and 4 and 5 and 7 and 8. So 2, 3, 4, 5. We don't have 6, but we do have 7 and 8. So the complement of that would be everything but that. So we should have 1, not 2, 3, 4, or 5, but we'll have 6, not 7 or 8, but we'll have 9 and 10. And then this is the same as what we did above, but we want to know how many there are. So we have 1, 2, 3, 4, 5, 6. 6 elements. Okay. All right. And then let's do some Venn diagram stuff. So you'll have stuff like this, where all I'm going to ask you to is to shade. Okay? It might be nice to have different colors. That might be good, either way. So we want to do the intersection of A complement and B. So first I'm going to color what A complement is. Again, it's everything but A. Okay, so that's A complement. And then B is all that, and we want to do their intersection. So what do they have in common? Well, it looks like that would be this. So where we have the red and the blue. Okay, let's try a pause and see if you can give B a try. So I think we're doing the same, we're shading the same stuff, except now we're doing the union. So again, we have A complement, everything but A, and then we're going to do B, oops, hold still, okay, and then we're going to union them. So we'll take all of B and all of A complement. So if we were to shade this, it would be everything that has color. So it'd be that little half moon that wouldn't be colored. Okay. All right, and let's talk about this one. So again, we can just color it piece by piece. Okay. We might be able to come up with this one by itself. What does A intersect C? So what they have in common would be this. And then we're going to union it to whatever B is. Well, we know that B is this. So we want all that's being colored, because we're unioning them. Okay? So it'd be that whole thing that's colored. All right, last thing we're going to talk about. If I give you a universal set, 1 through 3, come up with sets A, B, and C that would satisfy these two conditions. Okay, one thing I would suggest is just to draw a Venn diagram that would kind of model what's going on. Okay, so we have our universal set, and then we have 3 circles. One is B, and C is a subset of it. So we'll do something like this. And then we also have A, but it says that the intersection of them is empty. So they have nothing in common. So if there's nothing in common, then they're not going to cross each other. Okay? And then we just need to fill in some numbers that would make this work. So if we could do something like maybe 1 and 2 and 3 and 4 and 5. Could be something like that. So there's lots of different choices. There's not one that would make that work. Could have put the 5 here instead, or lots of different things. And then we just need to write down what our sets are. So for A we called is 4 and 5. B is 1, 2, and 3. And C is 2 and 3. So we can double check. Is C a subset of B? Is 2 and 3 in B? Check. And is A intersect B? Do they have nothing in common? Yes. So this would be a great example. Again, there's other ways you could do it. Be creative, and we'll be good. All right, well, if you have any questions, please let me know, and we'll see you later.